In this video, you are going to see about our final year project. Our project title is Performance Test on Diesel-Biodiesel-Propanol Blended Fuels in CI Engines. Our batch members are myself Ganeshias, Karthikeyan and Surya R. We have done our project under the guidance of Mr. P. Yogesh ME, Assistant Professor. Abstract. Increasing energy demand, depletion of oil resources have led the researchers to find alternative fuels for IC engines. On the other hand, palm oil can be used as biodiesel because it contains more fatty acids. Also in India, it is available in large amount. By transesterification process, palm oil can be easily prepared. Hence, it was planned to increase the combustion efficiency, performance and to reduce the exhaust emission by adding biodiesel 20%, propanol 10% along with the diesel 70%. Blending of n-propanol with the diesel reduces the brake-specific energy consumption at medium and high loads, but specific fuel consumption is increased when compared with diesel. Introduction. In day-to-day application, though the economic and environmental aspects do not agree to the usage of diesel, it is not promising to accomplish the habitual livelihood without usage of diesel engine. Also, emission from the diesel engine seriously distributes the living beings. This work was able to study the effect adding n-propanol with the diesel and biodiesel on performance characteristics of 4-stroke diesel engine. Objectives: the production of biodiesel from palm oil, the various molar ratio to find the high yield of biodiesel, to conduct performance test in diesel engine using biodiesel-propanol blended fuels. Methodology: collection of palm oil, production of biodiesel from palm oil using transesterification process, and third one is the performance test was done of blended containing propanol and biodiesel and diesel on CI engine. Before we have done our project, we go through lots of journal which relates to our project. Some of the journal are listed in literature survey. Materials requirement: for preparation of biodiesel, hot plate with magnetic stirrer, beaker, palm oil, sodium hydroxide, methanol, thermometer and separating funnel are required. For performance test, 4-stroke diesel engine, diesel, biodiesel, propanol are required. Procedure: preparation of biodiesel. Production of biodiesel can be done by various methods. One of the most common method is transesterification process. Experimental procedure for biodiesel production. It accomplishes 3 steps. First one, catalyst preparation, and second one, pre-treatment, and third one, transesterification process. Steps for preparation of biodiesel. Take 1 gram of sodium hydroxide is made to dissolve in methanol of 20 ml. Second step, fill 200 ml of palm oil in a beaker and made to heat about temperature of 60 degrees Celsius by placing the beaker in a hot plate with magnetic stirrer. Third one, now add dissolved sodium hydroxide in methanol and 80 ml of methanol with heated palm oil. And fourth one, maintain the whole setup at 60 degrees Celsius in hot plate with magnetic stirrer. Fifth step, after 30 to 40 minutes, formation of glycerol and biodiesel occurs. After completion of transesterification reaction, the ester mixture formed on the upper layer and the glycerol formed in the lower layer. The glycerol can be separated from the setup using separating funnel. The formed methyl alkyl ester is caused as biodiesel. Here the property values of biodiesel which is determined. This is the photograph of experimental setup. It is a 4-stroke diesel engine with mechanical loading. And now the performance test in CI engine. First, brake power versus SFC. In this figure, blue line indicates diesel and red line indicates biodiesel blended. Due to reduction effect of propanol on engine content of blend, there is a usually increase in SFC. Among the fuels tested, the lowest BSFC values are obtained with the diesel fuel due to low fuel specific consumption rate and high brake power. Here are significant increases in BFC, especially when the engine is fueled to 2 blends having high propanol content because of higher fuel consumption rate and reduction in brake power versus mechanical efficiency. Figure shows that the variation of mechanical efficiency for using diesel, biodiesel, propanol blended with brake power. There is a gradual increase in mechanical efficiency with respect to brake power. When compared with the diesel and blended fuels, blended has higher mechanical efficiency. Brake power versus indicated thermal efficiency. There is a gradual increase in mechanical efficiency with respect to brake power. When compared with the diesel and blended fuels, blended has a higher indicated thermal efficiency. Brake thermal versus brake thermal efficiency. Figure shows that the blending of n-propanol with the diesel shows almost the same brake thermal efficiency at low and medium loads, and higher percentage addition of n-propanol augments the brake thermal efficiency at high loads. The blending of n-propanol with the diesel reduces the brake specific energy consumption at medium and high loads. Conclusion: the blending of n-propanol with the diesel reduces the brake specific energy consumption at medium and high loads. From the above discussion, the blending of n-propanol with the diesel at optimum percentage may be recommended, and further researches in this area by advancing the injection timing and introducing the exhaust gas recirculation technique will turn out